Okay, in this video we're going to learn to find the difference of perfect cubes. A perfect cube is something multiply itself 3 times. In the previous video we did perfect squares, which would be something multiplied itself twice. Okay, so let's go ahead and do an example. All right, and there is something that we need to keep in mind. There's the difference of 2 perfect cubes, and there's the sum of 2 perfect cubes. The sum is the addition, of course, and then the difference is the subtraction. So there are 2 formulas that you're going to have to use. They're not difficult to memorize, you just have to know the signs. When there's the difference of 2 perfect cubes, it's a minus b. When it's the sum of 2 perfect cubes, the first part of the formula is a plus b. So that part is easy to remember. For the difference, okay, the a squared, ab, and the b squared, okay, you notice it's the same for the other formula, but the signs are going to be all positive for that part of the formula. When it's a plus, when it's the sum of 2 perfect cubes, then it's a squared minus ab plus b squared. It's minus plus. So that's the only thing you got to remember, okay? For this particular example, we're doing x to the 3rd power minus 64. So what formula are we going to use? Well, we're going to use the one that is a minus b, a squared plus ab plus b squared. Now, before we use the formula, we need to identify this as being my a term. My a term is going to equal my x cubed. And basically, I need to take the cube root of that. And the cube root of x to the 3rd power is just going to be x, because x times x times x, when you add the individual exponents, you will in fact get a to the 3rd power. And then this part here, okay, we're going to let b equal 64. Actually, it's really going to be the cube root of 64. And then, therefore, b is going to be 4. Okay, so essentially, if you want to be technical, we really don't even need to mention this right here. Okay, we can just say a is the cube root of x cubed, b is the cube root of 64. Take the cube root of those, and that's going to give you your a and b. Always designate a as your first term, b as your second term. Go in that order. Okay, now we're just going to plug it into the formula. Again, a is going to be x minus, and then b we said was 4. And then for the second part of the formula, we're going to do a squared. So that just becomes x squared plus a times b. Remember, if a is x and b is 4, then a times b is 4x. And then, of course, b squared is 4 to the 2nd power. 4 to the 2nd power is 16. Okay, so this would be my answer. All right, so let's do another one. Okay, so we need to check if 8x cubed is a perfect cube, and it is, and so is 27. So what we're going to do is we're going to let a equal the cube root of 8x to the 3rd power. And then b is going to equal the cube root of 27. Again, what times what is 8? Well, it's going to be 2. And then what times what is x cubed? It's going to be an x. What's the cube root of 27? The cube root of 27 will in fact be 3. Because 3 times 3 is 9, times 3 is 27. Now we need to pick the right formula. Again, since this is the difference of 2 perfect cubes, then we're going to choose this formula. Okay, now plug everything in. A is going to be 2x b is going to be 3. A squared is going to be, again, this is going to be 2x to the second power, just so you know what I'm doing. Plus a is going to be 2x times b, which is going to be a 3, plus, and then b is going to be 3 to the second power. So I'm going to show the steps so you know what I'm doing. Okay, and then we just simplify it. Again, 2x to the second power is 2x times 2x, which will in fact give me 4x squared. 2x times 3 is 6x, and then 3 times 3 is 9. Again, 3 squared does not mean 3 times 2. So 3 squared does not equal 3 times 2. Let's be very careful. What it really means is 3 times 3. So be careful for those little errors that people tend to make. And then this would be your answer, okay? Now we don't need to factor anything more, okay? That's it. All right, let's do another one. This one here is a little different because 4x cubed and 32 are not perfect cubes. So we want to make sure that, let's see if we can try to factor something out of here. Let's factor out a GCF and let's see what happens. What is the greatest number that I can factor out that goes into 4 and 32? Well, it has to be 4. Okay, so again, once you get practice doing the GCF, it'll become more fluent and then you can just factor it out right away. So it's going to be 4, okay? And if you're confused on that, remember what I taught you. Choose a number that goes into both of these, okay? And it looks like 4 is going to be it. 4 into 4 goes into it 1 time. 4 goes into 32 8 times. Now, is there any other number that goes into both 1 and 8 evenly besides 1? The answer is going to be a no. So we're going to stop. And then this is going to be my GCF. So use this method every time if you're confused. Okay, you'll always get the right answer. So we're going to factor out the 4. And then now we're just left with x cubed minus 8. Because 4 times 8 is 32. And then this is now the difference of two perfect cubes. So what we're going to do is we're going to let a be the cube root of x cubed and b equal the cube root of 8. So the cube root of x cubed is x and the cube root of 8 is 2. So now it's just a matter of choosing the right formula. Since it's the difference, we're going to plug it in. Okay, so we're going to use this formula. All right. Now plug it in. A is going to be x. B is going to be 2. A is going to be x, so it's x squared. A times b, again, if a is x and b is 2, then x times 2 is 2x. B squared, so if b is 2 and you square it, it becomes 4. And that is my solution. And don't forget, we want to make sure we put the 4. Remember the 4 that we factored out here? We need to include that with the final answer. Okay? That doesn't disappear. That's just the GCF that's factored out. So make sure you include that. Go back and include that. Because it's so easy to forget to do that part. All right? And that's the solution. Okay, let's do another one. Okay. Those two are perfect cubes, and now we're doing the sum of two perfect cubes. So we're going to use this formula, okay? A plus b, a squared, minus AB plus B squared. So go ahead and designate as this being A equals the cube root of x cubed, and B is the cube root of 1. So in this case, the cube root of x cubed is just x, and the cube root of 1 is just 1. So now we just plug everything in and we're good. A is going to be x, B we said was 1. A is x, so A squared is so x squared. A times B, again, is going to be, if A is x, B is 1, then x times 1 is just 1x, or just x. And it's minus, right? And then B squared, well, 1 squared is still 1. Okay, and that would be your answer. Alright, let's go ahead and do another one. So here we have y cubed plus 125. Again, A is the cube root of y cubed, and B is the cube root of 125. So the cube root of y cubed is just y, and then the cube root of 125 is just going to be 5. So now we just need the right formula. Again, since it's the sum of two perfect cubes, it's going to be A plus B. Okay, and then that's going to be A squared minus AB plus B squared. And now it's just a matter of plugging it in. Okay, so when we do that, we get, if A is y, then it's y, B is 5. A squared is, so A is y, so A squared is y squared. A times B, again, that'll be y times 5, so 5y. Plus, and then B squared is 5 squared, so that'll be 25. And there you have it. And that is the answer for that one. Alright? Okay. I hope that you found this video to be very helpful, and thank you for watching.